Welcome to my YouTube channel, Geekycodes. So, in this video, we will be talking about the 8 machine learning terms we should know if we are working in data science field, or whether it is data analysis or we are dealing with any kind of data. So we must know these terms as uh, these terms are very popular these days. And there are other terms as well, but I have sort out these terms based on like popularity and how often they are used. So uh, these terms we must know. So here we go. The first point is data wrangling. Data wrangling is, as we can see in this image, that the guy has been given a pile of that data, and from that he is finding out some structured data. That is what data wrangling is. So in by definition, data wrangling is the process of gathering, that is he is collecting the data and selecting selecting the data, and then cleaning that data, and then structuring the data and enriching the raw data into, like he's doing some operations on that data, so that that desired format is found, so that we can find out take some decision based on that data, like creating visualization, by creating some model. That is what data wrangling is used for. So if you want to like create an efficient ETL pipeline or create beautiful data visualization, we should know what data wrangling is and how to do it. Okay, so second point is data imputation. Data imputation is something called something like we have to uh, we have to prepare our data. We have to modify our data. So for example, we have some missing values in our data, or some there are some outliers as well. So outliers, you might not know what an outlier is. So we will be explaining that these some of these terms in a separate video. So you can find the link in the comment in the description as well. So to treat these missing values, outliers, and um, other type of irregularity in the data, we have to replace them with like mean or median. And so this is what data imputation is, like treating the missing values and treating the outliers. Data imputation is the substitution of estimation values for missing or inconsistent data items. Fields. Substituted values are intended to create a data record that doesn't fail edits. The most common technique is the mean imputation, as I told you, that to replace missing numerical values. To replace that, mean imputation is used, and to replace categorical missing values, we use mode, where we can take the mean of the existing data in that field and fill in the blanks with this. And to replace missing categorical value, we find out the mode of that column and replace that missing value or outlier with that. Okay, so that is what our data imputation is. So we move to the next point: supervised learning. super so Supervised learning is something like we are given some data, and we are given that this category output for this result for this data is this. For example, we are given details of a consumer. We are considering a classification problem. So for example, we are given details of a customer, and then we are given that this consumer is not going to do fraud with the credit card company, and we are given detail of another consumer, another customer, and we are given that this customer has done fraud with the company. So that is what our supervised learning data looks like. We are given the data set, and which has label which is labeled. So supervised learning is an approach to create a machine learning model where the program is given labeled input data and expected output results. And this machine learning model is specifically told to what to look for, like what is our target and what type of information we want from the data. So the model is trained until it can detect underlying patterns and relationships, enabling it to yield good results when presented with never before seen data. So that is what supervised learning is. Like when a model is trained, we are given the data for another different consumer, a different customer, and based on that data, we find out whether this customer is going to do fraud with the company or not. That is what our supervised learning means. The next term is unsupervised learning. In unsupervised learning, we are given an unlabeled data. Unlabeled data, what does data means? We are just given the features. We are just given the data. We don't have any information about our target. What kind of information we have to look for, what kind of the results we are expected to derive. That is in that case we have to feed our data to a unsupervised learning model, and then we find out insights from that data. And um, most of the problems are based on clustering problems. In unsupervised learning, a dataset provided without labels, and a model learns useful properties of the structure of the data. We don't tell the model that what kind of information it is going to uh, gain, but allow it to find the patterns and draw conclusions from the unlabeled data. Algorithm in unsupervised learnings are most of the time difficult than the supervised learning, since we have to find the structure and patterns and information from the data itself. So it is more difficult than the supervised learning. Unsupervised learning tasks typically involve grouping, as I told you that it involves clustering, grouping similar kind of examples together, and to reduce the dimensionality and to estimate the density. That is what our unsupervised learning model means. And so the next topic is classification. So as I mentioned earlier, that the credit card fraud detection. In that problem, we had to classify our customer into two classes. And uh, with actually what we do is we calculate probability of a customer of falling into all the classes, and based on that the class with the maximum probability of falling a customer each chose that this customer is falls into this category. For example, customer one has a probability of falling into customer class 1 is 0.1%, and into falling probability of falling into class 2 is 0.9%, 0.9. Then we find out that the customer 1 falls into class 2 category. That is what our classification is. So to when we come to the definition, a classification algorithm tries to determine the class or the category of the data that is presented. Many times an object might belong to several categories, and the AI needs to determine what those categories are and how much confidence and the algorithm has in its prediction. That is what our confidence calculation means. Okay. So the next thing is regression. Regression is like a type of supervised machine learning model, and in which level data is used to make prediction in continuous form. In As I told you that in classification there are classes given for a data point, but in regression for a data point a numerical value is given, and for the new data points we have to predict a numerical value. That is that is our regression problem. Yes, in this case, for example, we want to forecast in sales in the next year, or something like we have to predict we have to forecast the power consumption for tomorrow, and or something like that. We want to predict the like uh, expenses of an organization in the next month. These kind of problems that predict numerical values are regression problems. So the next topic is clustering. Clustering is a task of dividing the population or data point into the same similar groups. For example, as we can see here, we have the task is to divide to group all the red dots into one group, and all the black dots into one group, and all the green dots into one group. That is what clustering is. Like clustering is group of similar data points into one point, and another group of similar points to one group, and like that. So by definition, clustering is the task of dividing the population or data points into the same groups that are more similar eh, to each other in the same group than those in other groups. In simple words, the aim is to segregate groups with similar traits and assign them to clusters. So, our last point is evaluation matrices. So when, for example, we have created our machine learning model, how do we perform? How do we find out that this model is performing properly or not? And how much? How do we find out the performance of that model? So to find out, to find that out, we use an evaluation matrices. For regression, there are different evaluation matrices, and for classification, there are different evaluation matrices. Like for classification, there are precision, recall, and confusion matrix, and classification and accuracy. The F1 score. These are the things that these are the matrices that are used in classification, and in regression problem. Evaluation matrices are something like MAPI, mean RMSE value, um, and variance is also calculated to find out the to find out the accuracy or performance of the model. So these are the like eight terms that I have explained briefly, which are very important to know. And I think you have enjoyed the video. If you have enjoyed the video, please subscribe my channel, and comment your views below the video, and press the bell icon so that you don't miss a single video when I upload it. Okay, thank you.